Different metals like copper, aluminum, iron, and brass all have completely different linear expansivities. In our last video, we took some time to truly grasp what the value of linear expansivity actually means. But in this video, our core objective is to answer a fascinating question. Why is the unit of linear expansivity per Kelvin or per degree Celsius and not meters or centimeters? Let's look closely at the formula to solve this mystery. We already know that the change in length of a material depends on its initial length and the temperature change, which we call delta T. By simply rearranging that relationship, we get the exact formula for calculating linear expansivity, represented by the Greek letter alpha. Mathematically, alpha is equal to the change in length divided by the product of the initial length and the change in temperature. From this very formula, we can coin the official definition. The linear expansivity of a material is defined as its change in length, per unit length, per degree change in temperature. By breaking this fraction down step by step, you will see exactly why those length units vanish. First, let's look at the top of our fraction, the numerator. Here, we have the change in length. Because this is a physical distance, its standard scientific SI unit is meters. Next, let's look at the bottom of our fraction, the denominator. Here, we are multiplying two distinct things together. First is the initial length of the metal bar, which is also measured in meters. Second is the change in temperature, which we measure in Kelvin. So, when we substitute all the actual physical units into our formula, we get a fraction that reads meters divided by meters times Kelvin. Now, look at what happens mathematically. We have a unit of meters on the top and a unit of meters on the bottom because they sit on opposite sides of the fraction line. They completely cancel each other out. The length units disappear from the calculation entirely. With the meters gone, what is left behind? We are left with a simple one on top and Kelvin on the bottom. And that is how the mystery is solved. The units of length cancel out because linear expansivity isn't giving us a fixed distance like centimeters or inches. Instead, it is giving us a pure ratio, a fraction showing how many parts a material expands for every single degree of temperature change.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.